extremely honored to be here. And thanks for the friends who made this, helped make this happen. And the reason I'm here is I remember reading Lee's book last summer. And it made me realize that what makes a difference between people is not so much what they know, because I'm sure what you wrote about, every physicist may know. Or in economics, what I'm going to be saying, a lot of people are going to be saying, or have been saying, a lot of people know. The difference is to have the courage to take your ideas to the next step, the logical conclusion. And that's almost, it's so rare. Like, look in economics. You have how many economists, how many people like Nouriel can take the idea to the logical conclusion. Nobody has that courage. So I'm extremely honored to be here in a room where you have a higher density of these people than usually other venues. Thanks. I'm going to be talking about presenting ideas from what I call my next quadrant, about my fourth quadrant, which is focused on errors we tend to make and how to avoid these mistakes, particularly that they're related to small probability events. But before I start, I take my intuitions now from medicine, not from physics. I think that finance, and I'll show in a few minutes, is much more related. Economics is vastly more related to biological systems than it is to physical ones. But let me give you one quite sobering fact, is that if you stop people from smoking, your contribution to the welfare of mankind would exceed every single medical discovery and intervention of the past 60 years. So in other words, the person who discovered that smoking causes cancer, or smoking kills people, I don't know, we don't know his or her name, or I mean, few of them. I'm sure we can discover it, but it's not in the common consciousness that that person is an Einstein, but that think of the welfare that person added to the pot compared to the credit he or she is getting. And those who get the Nobel for things that are usually related to acrobatics. So if you tell someone, don't do this, he is not going to give you credit. It doesn't look scientific. Don't do this. And which is why the distance between the scientist and the charlatan has always been very narrow. Because a charlatan distinguishes charlatan from non-charlatan. Charlatans tend to tell you what to do. If you go to a bookstore, you go to Barnes & Noble. I don't know what the guys in Canada have the equivalent, I'm sure. You'll have hundreds of books telling you how to get rich in 10 steps, how to become happy, how to look good, and so on. Usually, they're useless, and they're typically written by people who never made it. And of course, empirically, this nonsense, what they have in them. But you don't have books telling you how not to get poor, okay? You don't have things telling you how not to blow up. You don't have memoirs, how I failed in life. These are empirically a lot more valid than how I succeeded in life, okay? Why I am a loser, right? And then the outcome, right? So you don't have these books. So which is why we have to worry. We have to make that big difference between positive and negative advice. The 10 Commandments survive. They're mostly negative advice. So what I'm going to be bringing in is mostly negative advice, but I know where to focus my negative advice, what to focus it on, what it should be about. What plagues us in economics is the difference between these two cubes. One is tacit knowledge. The other is explicit knowledge. Mathematical knowledge on the right versus experience on the left, okay? And that's the first point. In some other areas, the difference between the cubes is smaller. In economics, I think, I don't know if I underestimate how big it is, but I couldn't fit it on the screen, right? Okay? The difference between the two of them. And it's very easy to prove. In medicine, it's very easy to prove. You look at how much knowledge had been generated by the academy, top-down academy, versus how much came from practitioners, and how much credit the academy claims. So we discovered that because they're writing history books. In medicine, very easy to ascertain. You take experiments, and also, if the arrow of knowledge goes from propositional to the empirical, then you would easily see that knowledge should generated from knowledge, okay, should be able to discover things by sitting in an armchair. We don't. We discover things by trial and error, by tinkering. But in finance and economics, we managed to show and prove it in something called, commonly known as the Black-Scholes formula. I don't know if you've heard of that, which is neither made by Black nor by Scholes. It's just the marketing of an old formula that started a long time ago. And we discovered, I was a pit trader. My background, I was a trader for 21 years. I was a pit trader in Chicago. Pit trader did not wait for Myron Scholes to give them a formula to start trading, okay? They were actually using heuristics. Since 1870, you can document how people traded, and they did it in a vastly more sophisticated way. So there are a lot of things we knew what to do in tricks we discovered to make that happen. The minute we started being lectured in 1973, it started 73, it really started getting implemented by the time I got to Wall Street in the 80s. That top-down theory of why we need theory. It's just like, you know, you don't need Arrow de Breu to set the price of milk, okay? You don't need Arrow de Breu. People don't think of that, but you don't need general equilibrium models. So why do you need Black and Scholes and all these theories to discover the price of an option? The option is something driven by supply and demand, and then people back out a story to explain what it is, okay? That you realize we start getting in trouble. And this is what I say lecturing birds how to fly. They were lecturing birds how to fly, which worked fine because birds don't listen to humans, except that when you lecture humans how to fly, or at some point, you know, they start listening, and then they fly the wrong way, and this is what happened to us. So the wedge between the two is, and that's my next word, techne, episteme, experiential, propositional, in economics, and I'm extremely honored to have Barclay Rosser here, my new mentor in economics, Hayekian price formation as compared to central planner. You have basically a left column is the know how, and the right column know what. And what we can check easily the flows from the left to the right or right to the left. Typically, in social science, in the real world, the flows are in the opposite direction than the one you think, okay? Which means you can save a lot of money on tuition in Harvard. In Harvard, you're just buying a brand name because it's good for to be invited to dinner. Are you really buying knowledge or something else, okay? So, which brings me now to my own work on a false quadrant. And I tell you the two main problems we have are as follows. The first one is, I call it pre-asymptotics, is people take probability distributions as something like taken out of some Platonic world, some textbook, okay? And it may work, but it works asymptotically. It doesn't work in small sample, it doesn't work in intermediate stages. That's what I call the problem of pre-asymptotics. And on the right, and the other one is inverse problem, that we unfortunately do not observe probability distribution. We don't observe models, except perhaps, I think, in some departments, like in Harvard Business School, they observe models, but the rest of the world does not observe models, okay? So we don't observe probabilities. Probabilities is something we have, it's a fiction we have invented to describe something. So the non-observability of the generative random process leads itself to inverse problem, because you can have a lot of data and find a lot of generators to explain it. And actually, the degrees of freedom can swell enormously with some phenomena when you go into nonlinearities. These are the lines of research I'm following, and we'll see what they lead to. First, I bring in the fallacy of small probability. The Wall Street Journal in August 2007 had an article in which there's someone who actually I debated later on. He was employed by Lehman Brothers at a time when I started debating him, and he was unemployed when he stopped debating me for reasons you probably know, all right? And he was blaming me. He said, you're saying you're against models, it's like saying you're against hammers, all right? Okay, I don't use hammers for brain surgery, all right? I'm sorry. That was my point. But the gentleman made the statement that events we saw happening in August 2007 should have happened once every 10,000 years. And sure enough, we had 3 such events 3 days in a row, right? So luckily, the Wall Street Journal supplied the picture of the individual. And the picture shows that he does not look at all 10,000 years old, right? So when you say this event happens every 10,000 years, all right, where is your statement on probability coming from? Where? Certainly not from experience. So this is not an empirically derived statement, okay? It is not an intrapolated statement. It's not something empirically derived from the data. What is it? Where does it come from? From some a priori representation of the world, in other words, from some model, okay? So there we go. So we have the problem of small probabilities as follows. The smaller the probability, the less empirical your statement is going to be, the more it will need to rely on a priori. Very simple point about probabilities, small probabilities, all right? In other words, a 1,000-year flood, if you've been around for, a few years, you may not see it. Very simple, a simple point. Now, which brings me to one level higher in the discussion, is that the smaller the probability, the higher your error. So I said the more you have to rely on theory, okay? But the smaller the probability, the higher your error, measurement error, is going to be in a relative measurement of this probability. You agree? Okay. So in other words, a 1,000-year flood, okay, you need a lot of years, okay? And you're going to see much fewer 1,000-year floods than you see 100-year floods, okay? Or 5-year floods. So your measurement of these probabilities is going to be marred with higher fuzziness when you go. Very simple delta error, right? The error on that measurement. Now the problem is that in some domains, you have declining impact. You're multiplying. We don't use probabilities for entertainment, okay? For most functions. Most functions that we don't care about probabilities except some bets or some financial instruments. Typically, you care about expectation, which is probability times consequence, no? Okay, when you multiply the lambda, which is how much the impact is going to be, times the probability, you end up with a rectangle that's more and more stochastic at lower probabilities. Simple, okay? So that's the tragedy we have. In other words, the smaller the probability, not only the less we know about the probability, but the more it can, in some domain, type 2 domains, matter because it multiplies the probability with a huge impact, okay? That's very simple. This is a simple, so now I've explained everything. All my life I've been thinking. It took me about 20 years to be able to voice it. And it's going to take me another 20 years to be able to explain it, and then probably another 20 years to win the argument, and it'd be nice, all right? But it's a very simple point, okay? Now, which brings me to 2 domains. The one domain in which probabilities decline very quickly, and that solves the problem. That domain is, people say it's a Gaussian. It's not the Gaussian. We'll see later, it's not just a Gaussian. It's something that has, as you raise the deviation lambda, the probabilities decline too fast, so the error probability to matter for it. And this, I say, is something that converges to central limit in real time. And the second domain is no convergence to central limit in real time. The point is that, and I wrote a paper in complexity trying to explain the point, that the difference is not between things that have finite variance. People separate central limit into, they say, finite variance, you go to central limit. Non-finite variance, you don't go to central limit, you go to some other central limit, okay, called Levy stable, whatever you want, depends on, or you go nowhere, all right? But for me, no, it's in real time, because a lot of things have finite variance, as we're going to see, do not converge to anything tractable in real time. It converges at infinity. I don't know what you guys are going to be at infinity. I know I'm not going to be here, all right? So that's my distinction. Now, many people have heard of fat tails. So the second one is really fat tails. The first one is not fat tails. One way to represent it. Many of you have heard about fat tails. Fat tail simply means that the contribution of large observation, okay, is larger, okay? This fatness of tail is how much the total property is going to be explained by small number of observations, okay? Maximum fat tail is you have 1 million observations with no impact on the property, and one observation with 100% impact, okay? That's sort of like fatness of tails. That's one way to view it. There exists a measure in statistics of fat tails. What is it? Sorry? Kurtosis, very good. So the force moment, scaled force moment. So let's see if it's an easy problem. People have been facing economic data, say, oh, it's fat tails, but we know how to deal with it because we know it's fat tails and we have some paper on Poisson, Schmasson, all that bullshit. It doesn't work. Fat tails, if you say the phenomena is not tractable, is not of type 1, you're in trouble. Let me show you why. I took every single economic data that you can put on computers, all right? Every single one. I also took every single tradable piece of data you can, in the last 40 years, you can put on a computer, okay? Daily, weekly, whatever you want. Coconut, butter, cattle, this, I took them all right? It's very simple. People say sampling, we took everything. Why waste time? It costs $1,000 more, all right? Okay, take everything, took everything, every single commodity, all right? So I assumed that I got 97% of whatever was traded, or every single stock that traded everywhere. We took that, okay? We put it on the computer, very simple. And I did the following. I took, this is a sample of what we got, but of the main one, all right? I took the maximum contribution to kurtosis by one observation of the past 40 years. We have 10,000 observations. 10,000 observations I have for silver. Not 10,000 for silver, a little less because I took after the 80s, after the Hunt brothers. Sorry? Future started in 82? Yeah, but the future started after the Hunt brothers, or whatever, my data, okay, after whatever. The one observation in silver one day out of I don't know how many thousands represents 90-some% of the kurtosis, okay? It means you don't have that data in your sample, you're missing 90-some% of the properties. I took the stock market, US stock market, one day, October 1987, October 19, I think, all right? Represent 82% of the fatness of tails of the US stock market of the past 40 years. So when someone tells you, I know it's fat tails and we're going to adjust for it, he doesn't know what the fuck he's talking about. That's what it tells you. Sampling error. You realize that. That is, it's a very severe problem with fat tails. We don't know how fat the tails are. Okay? For a tractable security, okay, or for tractable, the maximum observation should be minute, okay, not that high. So you can do that with anything. You'll realize that when you take 40 years of data, if you don't have one observation dominating your properties, it means all you have to do is wait, okay? So the other thing is, of course, if you take any piece of data, you see no stability. 1 year you have a lot of kurtosis. It means that, well, now what is a kurtosis? It's fatness of tails, means what confidence you have about the variance. It tells us that we know nothing about the variance. The force moment is the second moment of the second moment, right? So the force moment is the error I have in measuring the variance. So it means that anybody using the variance needs to be stopped immediately, because in economics you cannot use variance. That's what this shows you, all right? You can use a lot of things, all right, maybe, but definitely don't use the word variance. Now, take every economic paper that has variance in it as we move to that, okay? Or take linear regression. What I say is I call it the L2 norm. Mean deviation is more stable. But mean deviation, we still don't know what it is, but it's more stable. Variance is much more unstable for reasons that are complicated here. Mean deviation is more stable. It's in the L1 norm, not the L2 norm, okay? So now with this data, I wonder what the answer is. Nobody has been able to answer me, okay? When I wrote The Black Swan, they started attacking me. They say, it's written like a raconteur. Of course, I sold 1.5 million copies. It's going to be written like a raconteur, all right? It's a literary book. Why the fuck don't they attack this, all right, this point, all right? So instead of going, it would mean that there's no answer, which means to me that anything done in economics in some disciplines does not exist scientifically based on this. It's just sampling error. All they do is narrating on sampling error. If we shut down the economics department, we would contribute to knowledge immensely, all right? Just based on that, okay? Linear regression, anything, doesn't work anymore, okay? Let me continue. Another thing is that they say that, well, you know what? If you use daily data, you have fat tails. But you start aggregating, tails get thinner. Of course, tails get thinner because you have a lot more observation in the beginning, but at some point, they jump back up. This is a kurtosis on the temporal. I took every single security and started lagging. You see kurtosis dropping, and then it goes back up because you have sampling error makes because affects rare events more than others, makes kurtosis drop, okay? As you go from 1 day to 5 days, you're aggregating data. So you have the feeling things are becoming Gaussian until they stop becoming Gaussian, all right? So the 30-day kurtosis, there's no evidence that 30-day kurtosis is lower than 1-day kurtosis, and so on. This is what you see, okay? Well, we have a problem, okay? Now, move to power laws. I'll get into some power law properties later. But we have another big problem, is we don't know how to calibrate power laws. I tried to calibrate power laws for about a decade. And depending on the day, if it rains or doesn't rain, I get different exponent alpha. Minute differences in alpha, this is a distribution of 40,000 observation of the power law tail of a security. Minute small differences in alpha can cause rare event, the shortfall expected to jump up, okay? You multiply it by factor of 20, you know, so based on just mean error that you have in measuring the alpha, which tells us one thing. Let us not depend on fat tails. Simple. You can do a lot of things if you just make sure you don't depend on fat tails. That's my message, but let me continue here. The gentleman, Nouriel was very generous towards them, went to DC and went to the Congress, and what did he tell Congress? He told them, these events never happened before. No? Okay. It's like I'm saying, him, if he dies, I say it's impossible, all right? Because he never died before. Right? I mean, this is like, so what happens to you, the minute you study too much economics, you lose the stuff. I'm sorry, no, except, of course, under some of my friends who are here today. You start losing some elementary logic, all right? This is not empiricism, but say it never happened before. So let me tell you what I did. So but there's a simple test to figure out. When the stock market crash of '87 took place, all right, people were stress testing like these idiots are doing now in Washington. Sorry to use words, but you gotta, you know, that's reality, all right? You stress test based on the past, okay? The worst deviation in the stock market was the order of 10%, 10, 11%, historically. Then we had a 24% drop in stocks. So that event did not have a predecessor, okay? After that, I couldn't understand why what people were doing on Wall Street. They kept stress testing to 23%. See, if you stress test before that event, you would stress test to 11%. So in other words, there's some autism in understanding the wheel of that history runs forward, not backwards, right? Mental blindness towards the fact that if you take the past's past, and the past's future, okay, that relationship got a hold, okay, with respect to today, its relation to its past and today's future, okay? He didn't get that point. But let's put some empirical thing on it. I took every single measure of shortfall you can find. In the axis, vertical axis, I have a shortfall. Shortfall means average loss beyond, say, 7%, 6%, 5%. I did it at different scales, okay? And I tried to see if at period t plus 1, t plus 2, t plus some lag, all right, that it would predict itself. So in other words, if events if large deviations have predecessors, okay, it should show a graph like this. You see? It should show a cloud like this. Look at the cloud you see next to that guy, Greenspan. It tells us that If Mr. Greenspan had a computer and he has some staff, all right, and tested if rare events have predecessors, he would have seen that rare events don't have predecessors. Okay, that's simple. It's just like people, let's say people need to die before so they become, empirically capable of dying. Same reasoning, right? So there is some autism in the way people analyze that usually comes with a PhD in economics, typically, all right? So, except, of course, for Nouriel and other people. No, there is some, not all, sorry. Some, okay. But some people are good enough that they surmount that, all right? Like Richard, Nouriel, and some other people. So, this I could not understand because all my life I've been fighting, okay, these stress tests done on the past. If you stress test the world before the first war, you would not have stress tests to events of the first war. So there's something that in the stress test that doesn't make sense, okay? But things are going to get worse, all right? The other problem is, Nouriel discussed it, the problem of a turkey, is people produce a lot of profits, and then some quant gives them a sharp ratio and all that, okay? And sure enough, when they lose money on the right, they lose back everything, okay? It's the story, my story of the turkey. They lose back everything. But meanwhile, you have someone like this analyze it and call it the great moderation, right? Why does he call it the great moderation? Because it's very moderate. It's like, banks are hiding a lot of risks, but they say, oh no, empirically, it's a very stable, low variance environment, as if variance had anything to do with anything. And of course, there is a difference. Upstairs, you have a thin-tailed noise. On the right, I have fat-tailed noise. When you go from thin-tail to fat-tail, observed volatility drops because more of the volatility is going to come from spikes. So sure enough, you're going to say it's a great moderation, all right? Intuitively, let me give you intuitively, take a Gaussian. What's the probability of being between -1 and +1 sigma in a Gaussian? 67%, all right? Now, if you fatten the tail, what happened to that probability of staying within -1 +1 sigma? Sorry? It climbs, all right? It climbs. So what happened is that if you fatten the tail, conditional on having the same volatility, all right, you have the illusion of no volatility most of the time. Because when it goes, you have fewer large deviation, but when they happen, they contribute more to the properties, all right? So it makes sense. Yeah, so when you see, so people just mistake volatility. Volatility is not, we saw as a poor measure, but we saw how it can mislead people into anything, making any statement, like the nonsensical statement by the gentleman here. If you numb the market, okay, it has a lot more risks, okay? It's going to be more, if you sell out of the money options, they're going to blow up less often, all right? So you're going to have the illusion of stability at the expense of bigger risk, okay? So that is what this wedge we have between events, the nature of the dynamics of the process in which we live on the right and the dynamics on the left. So banks, of course, are going to blow up because they don't know about hurricanes and spikes like that. That was my idea of why the banking system should have blown up, except that I thought it was going to blow up in 2003, and I had to wait an extra 5 years, which is very painful, all right? But worth it, okay? Left tail. The other problem we have with left tail is if you just have something with skewness, in other words, only exposed to left-tailed events, not right-tailed events, it's going to produce illusion of stability. Why? Necessarily, as I said, you're going to have fewer 1,000-year floods than 100-year floods. So there's the zone on the left, the invisible left tail, that when you do a histogram of empiricism, someone like Greenspan would do a histogram, would completely miss that part, the blue, okay? The invisible in the data, but yet very important for the properties. And there's another bias we have linked to the survivorship bias that tells you that whenever you observe a random process and the probability of survival of that random process, okay, depends on its survival, the computational probability depends on its survival, okay, and then you have that's the anthropic bias, you have a overestimation of some classes of properties, okay? So if you take things that have survived, necessarily that survived. It's best phrased with a statement by my friend who said, conditional on my being here, I did not need health insurance, okay? You see, conditional on my being here, I did not need it. If you're talking about life, okay, odds are and you can't talk about probabilities, which is something in theology that is very interesting when people talk about probability in theology. Dependence on. And sure enough, after this left tail, I had the gift of witnessing last year that so my statement is if something is likely to blow up, okay, whenever you take a past measurement, it's going to overestimate its mean and underestimate its mean deviation, all right? Sure enough, that's last year. Okay, last year, this is a histogram of 100 and some years of stock market returns. And that was last year, okay? And you can expect, the future to have more left tail than the past. Okay, so anything you see is going to be rosier. Finally, let me introduce one fallacy. Someone should explain the government very quickly. There's no such thing as a recession. It's what I call the fallacy of single event probability. There's no such thing as a war. In fat-tail processes, there's no typical event. And there's a measure for that. There's no such thing as a typical war. A war can be Argentina, UK, and it would kill less people than Argentinians in a bar at a soccer match, right? Or UK people, and you see, it actually, maybe reduce mortality, all right? But say the maximum number of casualties is 3, and then you have the world wars of 70 million combined. So a war, what does a war mean? Like you can predict a war, like you predict an event. That's about prediction markets. That's my discussion, about prediction markets. We predict a crash. What does crash mean? 10%, 20%, 70%? We don't know what it means. What does success mean? People think, I'm going to be successful, have 5 million, or successful, have 50 billion, all right? The distance, and you can see it in estimation of drug sales. They think those who thought that the drug would be successful, when you look at estimated sales, it's the same thing, totally random on a map, okay? And this is easy to measure with the notion of conditional expectation is what is the expectation of a random variable, conditional on that random variable being higher than k, all right? Let's take that in the black swan. The first example I took is age. Age is type 1 randomness, okay? Near Gaussian type 1 randomness. Life expectation at 0 is what? About 80, no? Once someone reaches 80, life expectation is, say, 92, all right? Okay. As you raise k is 80, all right? Conditional expectation is 92. If k is 100, conditional expectation is what? 102, all right? And k is 160. This is right, 60 plus a billionth of a second. All right, yeah, he's dead. All right, okay. So as you raise k, all right, the things converge. That's in type 1 randomness. A very simple thing that higher, conditional on being 10 sigma or higher is 10 sigma in a Gaussian. All right, but conditional on being higher than 0 sigma is 8/10 of a sigma. We understand that. It's very simple. It creates a typicality of an event. The problem is I took financial data. I got bad news for you. I used mean deviation. Conditional on something being higher than 2 mean deviation, then it's about 3. Conditional on being higher than 10 mean deviation is about 15. Conditional being higher than 20 mean deviation is about 35. That's for macro data, okay? It means there's no scale. There's no convergence of conditional on x higher than k. Sorry, as you raise k, the conditional expectation rises as a parameter that you never know, as a constant times k that you never know. For a power law, it's linked to alpha, okay? So in stocks, it's worse. Conditional on something being higher than 100 mean deviation, any scale, 1 day, 1 month, whatever, it can be 300 mean deviations, okay? And conditional on, we have things higher than 200 mean deviations, all right? Which is crazy, but we found data. We had 7 or 8, things higher than 200 mean deviations, and it's all over the map. Okay, so there is no scale. It tells us the following: there's no particular typical event in a fat-tailed world. So you can't say a success. You can't say a big bonus. A big bonus when I joined Wall Street was $30,000. I didn't know that one guy is being paid today $100 million, and some people have gotten billion-dollar bonuses, all right? So there's no scale of what a big bonus is. There's no scale in these things, all right? So in book success, the same thing. So lack of scale impedes on risk analysis heavily when you take a typical one. You have to take something richer, all right? Second point, we started doing psychology. Goldstein and I did some psychology to look at intuitions of people. Do people get that intuition? It looks like they get the intuition of conditional expectation, that one, conditional that x higher than k, they get it in the right domains. We tried, that domain was in market cap, they didn't get it right, okay? But they get it right for height, for example. They get it right for a lot of things, but not for stocks. So it looks like the two classes of random variables. One class that we created, stocks, information random variables. And we don't know how to deal with them intuitively. Even professionals don't know how to deal with them intuitively. So Goldstein and I have been doing some mapping of these, and it looks like it lines up very well. We don't have good intuition. Experts are pretty much pseudo-expert in these because they use wrong metrics, but it's intuitive. And the most disturbing is something we're going to prove, he and I, when say, oh, I know people know the model doesn't work. That's not how it is. If you give someone, we're going to prove, if you give someone a value at risk model, tell them it doesn't work, he's going to take more risk. And we'll have the evidence. I mean, we have the evidence. It was just a matter of formatting it in a way not to have someone attack us too viciously, all right? So there is a problem with, we humans aren't very good with knowledge, okay? And with that, the flow from episteme to techne can mess things up with those not smart enough to handle it. So don't give, this is what in my 10 principles that were in the Financial Times, I said, don't give a child a dynamite stick, even if you have a warning label on it, right? I mean, it's so obvious, like saying someone, I gave him a pack of cigarettes, but it's right, smoking is bad for your health, all right? Models, some idiot said, all models are wrong, but some are useful. I say, some are harmful, all right? Okay. That's what I say, all right? So that can be harmful to give models to the wrong people, particularly say something like Société Générale or some other firms. No. What's the solution? I don't have a lot more time, no? Okay. I did something. I started looking at payoffs. How do you use statistics? We have two kinds of payoffs. One payoff, I call it simple, which means true, false. Like if I'm betting $1 with you or prediction market, okay, will there be a crash? It's true, false. That's a simple payoff. I got $1 if I'm right. And this I learned from binary options. These payoffs are completely insulated from fatness of tails. They're tractable. You know, they depend on whether you exceed a number or not how much you exceed it. So if you're doing an experiment in medicine, in anything, you say it's true or false, you know if it's true or false. Okay, so the true-false payoff is because it's simple payoff, simplified payoff, true-false. And then you have complex payoffs. The first one visibly depends on expectations. So the first one is a medical test. The second one would be an academic, all right? It's not true or false whether it's how many people the disease has killed, and effectively, it's usually a fat tail process, okay? So you have a richer set. And then we have, in finance, they create even something worse. It's expectation, but nonlinear expectation, where you have LIBOR square or payoff, you know, linked to variance or things you square, and it gets even worse, okay? Very complex payoffs. So you have payoffs. Simple payoffs don't depend on fat tails, all right? And then you have two distributions. You have a type 1 distribution and a type 2 distribution. You agree? Type 2 has fat tails. So my idea is that if you have simple payoff with fat tails, things work. The integral, okay, even if you have infinite expectation, all right, the integral, the probability, you know, everything works, okay? So by truncating, you move out of what I call the fourth quadrant, which is a second type of distribution with complex payoffs, okay? So you can move out of the fourth quadrant by reducing by clipping, by lowering the worst case scenario by doing things like that. That's my idea of fourth quadrant. And of course, I've rephrased this in a more literary form, things I call the barbell, things. A lot of things depend on this representation of fourth quadrant, okay? You know here limits of statistics, complex payoff, and second type distribution, all right? You can no longer use statistics because we don't know what the fuck is going on with tail events, and you depend on computation of tail events massively, disproportionately large. It's a very simple statement, no? The rest, you can do whatever you want. Do whatever you want in the middle. The problem is that there's too much in the fourth quadrant to clean up. That's my idea, that's my proposal. Getting out of the fourth quadrant. So I'm pretty much, I would like to take some questions because if I have 5 minutes, I'd love to take 2 questions because Doan Farmer promised me that he will ask me a question. He didn't, all right, during the talk. Okay? You can reduce fragility massively by doing this. Reducing debt, for example, move you out of fourth quadrant. There's one thing I have to say, is that the fourth quadrant has effectively two components. The thing is a little richer. I discovered that payoffs are either, typically you depend on the right side, okay, you're skewed right or skewed left. In other words, you're long an option or you're short an option. In other words, a bank, okay, cannot suddenly make a fortune. It can either, the insurance company either is hit with a tail event, okay, to be hurt, or have no tail event. So there's some businesses that have unseen positive tail events in them, say venture capital. So I reclassified exposures into convex to tail events and concave to tail events. And that convexity to tail events effectively maps into convexity to model error. Okay? So some things benefit from model error. Like I own every single out of the money, all right, I can on things that benefit from hyperinflation. I stated this is my new trading thing, all right? I own out of the money options, all right? Now, if I'm wrong, I lose little in my representation of the world. If I'm right, I make disproportionately a lot more. So I'm convex to model error. I'm convex to uncertainty, higher order uncertainty or model error, right? So this is, you have to distinguish between these two in the fourth quadrant. So I'm saying, what I was simplifying when I said get out of the fourth quadrant, my point is get out of the left exposure, tail exposure in the fourth quadrant, okay? And I'm glad you debated Romer, because if you really understand that economic growth comes from positive, you know, exposure to model error, okay, in the fourth quadrant. Not directly from technology, but because technology, usually people design technologies for something and it's used for something else. Because model error benefits us there. That's sort of what I'm taking everything. So that's sort of my idea, my main idea, is to promote the notion of convexity to model error. So I'm pretty much, I'm done, and I can take questions. Thanks a lot. Yeah. How many? Two questions? All right, yes. No. What I had before was I had E of X. What I was doing is, okay, what I had here, okay, here I have sigma. I did that in sigma space, but it's, this one here? Okay, the graph here, okay. Yeah, I see that the Goldstein with the Goldstein work. Yeah, there you go, okay. What we had here is you take the responses, as you're raising, you raise market cap, you say the market cap is 20, what's the expected market cap conditional on it being higher than 20? So I have the normative, which is the empirical one, and I have what people's perception is, what it should be based on that. And you see the line, sorry? It's a survey question, yes. It's not a tradable question. I think he was raised to it, yes, go.
Just a couple. When you talk about the fallacy signal event probability, it's not just like 90 and uncertainty. And if you go through that with respect to the uniqueness of economic, political events, is underneath your analysis basically rejecting the ergodic assumption about the economy?
No, I'm not getting into that because this ergodic assumption means no path dependence, you mean? Let's see. Okay, I'm a simple guy, all right? I deal with simple things. I say I don't understand because the idea of the two kind of people, those who want to understand what theory a process can lead to this result, the other one, like me, who just describes things statistically by saying this is how it is empirically. I don't want to understand too much. And this, I called it, in my new book, I try to find a name for it. People don't have respect for you if you tell them I don't know unless you give them a name to what you don't know. And I call it historia sensate cognitio. Okay? Taking history, there's deduction, induction of these theories, but there's a way to accumulate historical fact, all right, without making sense from these facts. Okay? Just accumulate them without making sense from them. All right? in a way, was that too much causation? This is non-causative historical stuff or non, okay. This is sort of like my new approach, to stay in the episteme, in the techne, not the episteme. So you may be right, there may be some process that can work, but I don't want to know about it. It's not my business. I'm interested in surviving to make it tomorrow. I'm interested in model error. Okay, we're done. Great, thank you very much. Thanks.